really just a brief introduction. I'll let Mike go on this one. If you guys got questions along the way, just chime in real quick. We can backtrack. And again, this is something we can do over and over again. So if there's more information you need afterwards, don't hesitate to ask. We'll do it again. So Mike, go ahead and I guess get started.
Okay, thanks, Mark. Yeah, this is SprayVision, and as we were just saying, took it over in November. This is brand new technology. This was developed in 2018 and introduced to the market in 2019. So it's really new out there. As Mark mentioned, it was developed by a team in the Czech Republic. And these are a bunch of really, really smart young guys. And they're addressing a need that's really never been touched before. So it was voted last year in Vodafone's Best New Ideas of 2020. It actually was voted #1, which is kind of cool. It's very, very unique. This is oriented for your paint customers, and it's going to address 2 key problems that your paint customers have. #1, setting up new parts and new colors. And then #2, making sure that every time they run those parts and those colors, that they get the predicted results. And this is a completely different approach to simulation and all of the things, all of the tools that are currently available. So let's jump right into it. You can see, looking at it, that it looks like a standard flatbed scanner. And in fact, if I open it up, it still looks like a flatbed scanner. This allows you to measure actual applied paint while it's still wet. It's kind of interesting. Whereas your normal flatbed scanner has a carriage that runs underneath, this does as well over a glass bed. And this is not your typical HP scanner. This is metal. This is real glass. This is good stuff. It's industrialized. It's made for an industrial environment. But this lights from above. And what you can't probably pick up well in the camera shot, this top is recessed around the outside. So there's no contact with whatever you place on the scanner. So how does this work? Well, we're all used to, in the paint industry, to shooting a test shot. You come in, you start out, and you take a test shot. Now, this is a typical gun, and this is the A3 unit, and it's named A3 after European paper sizes. There is another unit, twice as wide, that is called the A2 unit, same size as A2 European paper. It's designed for bell patterns, which are large and square, as opposed to being oblong like a gun pattern. This one's easier to move, and I don't need a wide angle lens to get it on camera, so that's why we're using this. But you would normally shoot this pattern on craft paper, and you'd take a look at it and you'd say, okay, I can see my pattern, it's about the right size, it's about the right density, I think I can make that work. Now, here what we've done is we've sprayed this on a Kapton foil. Now this happens to be dry, but I could have done this just now and it could be wet. I can lay it on the surface of the scanner and then I can close the lid. And lo and behold, I don't get paint on the scanner. Now, the scanner connects to the computer through a standard Cat5 cable. And then the computer connects to the internet and to the software in the cloud. All of the software is virtual. All of your storage is in the cloud. Beauty of that, I can have this down at the paint line. I can scan as many things as I want. I can store them in the database, which we'll look at in a minute. But then I can go back to my office. I could be sitting at home with my feet propped up and a beer on the table and be working on the captures that were done today. So there's a lot of things that you can do for analysis, and you always have access to this wherever you are. So that cloud-based software is important. Nice thing about the cloud-based software, it's always up to date. And so you've always got the best features, and the bugs are fixed continuously. So it's not like waiting for an update like you do for your computer or your phone. So let's take a look at that software real quick. I'm going to do two things here. One, I'm going to share my screen, and I believe you should be seeing the SprayVision screen. Mark, is that correct?
Yeah, I got it, Mike. Everybody should have the same, I hope.
All right. That's not what I want. We're going to try that again. That's what I want. And then I just log in. Now, you can have as many logins as you want. It's got full permission capability, so you can set up different users with different capabilities. So you can have managers, you can have paint operators, you can do whatever you want. As I mentioned, this has a full database built into it, and it works just like the standard folder system. You can see we have a root directory here, and then we have folders underneath. We can store things in the root, very similar to what you have on your computer every day. And so this is very easy to work with. Down here in the corner, we have the camera. This actually grabs access to the capture unit. And what we're going to do very quickly here is we're going to capture this. I'll get into details on the capture in just a minute, but you can probably see on the camera that the light is on in here and it's lit from above. We are actually reading the intensity of the light coming through the paint. We talk about paint hiding a lot, but what we don't think about is the fact that even though the paint gives us good color, good hiding properties, it's still pretty translucent. The reason that it does what it does is because it's on a solid background. The light is only coming from one direction. Here, we're taking advantage of the light coming through the foil. And this Kapton foil actually can be heated to, I think, 200 degrees centigrade for up to 10 minutes. So you can easily run it through your cure process. We'll understand why that's important in a minute, but in general, the best part about this is the ability to scan wet. You don't have to wait for the cure process. So you can spray your foil, take your measurements, get your analysis, and be ready to make adjustments and start over again before you would ever have gotten through curing in the first place. And you're not wasting any parts. Very important. Now we can see that this went through the capture process and it actually uploaded it, it saved it, and here's our pattern. So what I'm going to do is I'm going to load that, and then I'm going to run up to spray capture. And we'll be able to look at this pattern, and you'll see instantly the difference that you can see with the foil other than what you would see on craft paper. Here we can see the original scan. The blue is all open area, but now we can see here exactly what our concentration of paint is all the way across the scan and all the way across the pattern from top to bottom. We can see it in 2D like this, and it's displayed in the common FEA heat map type thermal photography platform that we're all used to, and that makes it really easy to interpret. Where it is more red, where it's hotter, the film is thicker. And you can see that it's actually reading out in micrometers right now, microns. And that micron measurement is dry film thickness. And I'm going to show you how we get to that in just a second. But we can not only see it in 2D, we can see it over here in 3D. And we can grab this image, we can rotate it, we can look at it, we can see what we've got. We can see where we've got our hottest spot here, where it's the thickest. We can see what's happening out at the other ends. And we can see that our pattern is actually shifted here towards the top. So this means if I did a 50% overlap, I wouldn't get as even a coverage as I would imagine if I were just looking at this on a piece of craft paper, white or brown. So that's really important to us. Now I mentioned that we're reading out in dry film, and we're going to talk about how that happens. We're actually able to calibrate the unit, and you have to calibrate the unit for every paint and every color. And so give me just a quick second here. There. I want to get back to the camera. To calibrate, we take this special foil. It looks just like the foil that I held up before, except it has a grid on it. And we use drawdown bars that are sized to this specific grid. So that's another item that gets sold along with this unit. And you draw down and you get different film thicknesses on here. You lay this on the surface and you scan it. And then you cure it in a lab oven or whatever. Run it through your process and you cure this. It's the only time in the process where you have to cure it. Then you lay it down on a metal substrate and you take your standard film measurement tools that you would normally use in production, be it Alcometer, be it Defelsco, be it whatever you're using. And you literally measure the film thickness in different areas. And then the software actually allows you, if I can find this here, we'll go to calibration. I'm going to go back to sharing the screen again. And it allows, and I'm just going to show you one here. I'm not going to go through the whole process, but this was done actually off of this. And so you measure different places and you find the intensity in the unit and you match the matrix. You find the square that you're looking at. Say, well, for this square, my film is read out as X. And then you enter that in here. And you can see that the blue points are actually the entered points. Having a little trouble here getting that. The blue points are actual, there you go, measured data. And then the orange is the curve fit for all of these data points. And this allows us then to convert the intensity, how much light is coming through the film, to the actual measured thickness, dry film thickness. So now the measurements were originally taken, they were scanned in the wet, measured in the dry, and then correlated here. So now I have a calibration file for this particular coating. And I just do that for all my different coatings. And I can call that up. This happens to be the one for these foils, and these were done at CFAN in Texas. They do turbine blades for jet engines for General Electric. Pretty high-tech product, very impressive facility, loads of fun. But we did this work there. And I can call this up at any time. In fact, when I scan, you can see that I've assigned the CFAN profile. And I've also assigned the CFAN calibration. Well, that means that this calibration file will be linked directly to the scan, and that's why all of the measurements come out in dry film thickness. Now, I can assign that after the scan's been done. But if I do it when I set it up, and I'm probably going to be working on a part and a color, I can set all of this stuff up ahead of time, and every scan I take is automatically assigned all the proper parameters, and it's attached right to that file. When I go to look at it later, it's going to help me. Okay, now, we looked originally at yeah, there it is. I didn't want that. There we go. We were looking at this. Now that's my gun pattern. It's called a static pattern. And that's important to how the gun is performing. What's really important to us is when we put that pattern in motion. So this is that same pattern placed in motion. This is called a dynamic pattern. And we're going to scan this pattern here. I should still be showing my screen so that you can see the whole process. I can select different kinds of patterns. I've showed the calibration already, and we'll talk about droplet analysis, process control, and then stripe and foil crop. I'm going to talk about while this is scanning. Right now, I want pattern analysis. So while this is capturing, you can take these foils and you can actually apply them to your product. You can cut them in different shapes to make them fit into curves and that kind of thing. You can attach them, for instance, on a car body or something like that. You just put the whole film on there. We did that on those fan blades, and you actually get all of what your robot path is laying down. If you have complex areas, you can see now we're processing. It will upload in a minute. And come on, where's my mouse? There it is. Back over here. Let's say you've got specific areas, complex shapes, things that you're trying to catch. You can get the Kapton in a tape, and it is 20 millimeters and 40 millimeters, and you can just stick this right to your parts. For specific points, these are little dots that you can actually peel right off and stick right in a specific point. So if you got like the curve inside of a door, or a point on a mirror, say right out at the point at the aerodynamic front edge, you can check that point, specific point that your customer will be checking, by simply applying points and then using the foil crop features. Now, when we put this in motion, I know I'm jumping around just a little bit here, but I want to make sure we've covered everything here. Let's go look at this pattern. This is our dynamic pattern. We've taken that original static spray shape and we placed it in motion. So let's take a look at that. And here we go. Now here we can see the pattern shooting across, and that looks pretty even. It looks pretty good. But when we look at it here, we can see that it, just like we saw before, we saw that point was off center. The peak concentration of paint was off center. That is reflected here, and we can see that that is off center. We can see it when we look at our 3D pattern. We can see that it's actually shifted, in this case, off to the right. So now we can see exactly what's happening in our laydown, okay? Now, if we take this and we transfer this to our foil, there we go. Let's say that we take this and we place this on our part, and that's exactly what we did at CFAN. We applied this right to the blade and we taped all around it, and then we went through and we did the normal robot pattern. And we look at this, and even holding this up where the light can come through it, it looks pretty good. And we're pretty happy with that. But the indications would be from this dynamic pattern and what we saw there, that it might not be as even as we think it is. And that's probably why I chose these slides to show you, right? Because they do show exactly what we're looking for. So I'm going to come in and I'm going to scan that. Now, what this means We take the foil, we apply it to the product. We run our normal robot routines. We go in, we peel those off. We haven't cured it yet, it's still wet. The whole process so far has taken 5 minutes. We lay it down, you've seen the time it takes to capture. So we're gonna add another minute or two. We're gonna capture this data. And then we're gonna look at it and we're gonna see the result of our actual painting process on the surface of our part, because all we've done is shifted that by 20 thousandths the thickness of the foil. So now we're going to get very accurate information about the setup of our painting process. What we're actually looking at right now is with these, we can identify the output from our specific brush settings. And then we can see that it's already captured, it's already put it back up. I'm going to run out and I don't have to go to the database. I can just click select. I can find that one that I just did. There it is. So let's pull that up. We can see the width, we can see the height, we can see everything about the output from our atomizer for this particular brush setting. And then we can go back and we can see exactly what it looks like when it's applied to the part. And even though it looked like it should have been smooth, we can see that we have 30 microns in this area, but over here, we're actually down, there's 22, over here, 15, 14. Half of the paint that should be applied. Looked pretty good on the part, and yet here we can see that we have a problem. In 3D, yep, there's the hole, there's the unevenness, heavy around here, big hole in our paint. Obviously that's an issue. I mean, think about this. This is on a jet engine turbine blade. Find me one thing in the world where balance is more critical, where even film is more important. And yet this is what they were producing with their robotic spray system. So seeing this, I can look at this, I can analyze what's happening with my robot pattern. I can go back and make corrections to my program, and then I can reapply the next foil. I can rerun that program, spray the part, pull it off, scan it, and I can see if I've successfully corrected this problem. And I still have not yet cured a part. So that multiple hour time, I mean, in an automotive plant, it can take 3-4 hours to get to the other end of the line and start taking that data, and you have to take it with an alcometer or a DePelsco or whatever. You got to take all of those different points. Here, you're not getting individual points. If you chose to measure here and it came out fine, you'd say, that's great. Maybe not even realizing, or you got out here and you said, well, I'm a little light, but it's not too bad. Whereas if I had just moved to the left or the right, just a little bit, I can see that I have real problems. This gives you the entire picture of the entire paint area. So this allows you to fine-tune your parts very, very quickly. So when you set up for a new color, you can fine-tune it and get that robot program working perfectly. And all because you were able to set up, test your brush settings, and check the way the paint is applied to the part. Now, that leads us to, great, I got it today, it's wonderful. Next week, I want to run this part in production. So how do I make sure that I'm going to get the results that I set up today? And the answer is to make certain that your spray pattern from your atomizer matches exactly what you used for your setup. So for that, you set up a golden standard, and this provides an option for process control, I'm just going to use the metrics real quick, and I'm just going to use some files that I've got scanned in here to show what's happening. To start with, I'm going to select a project. I'll use this one. It's our training project. And then it's going to say, here is my gold standard. This is my gold pattern right here. Now, I can walk up. I can put a foil in place, and most lines, they just simply make a fixture where this always goes in the same place. You walk up and you set it down, attach it to your fixture, run your program, and the robot comes down and it shoots this pattern very quickly. It's always the same, so you always have a reference. And then you scan that. And then I run out and I bring that pattern in. And let's just say I'm going to run this one. Here's the one I just scanned. And it pops up and it shows me all of my relative measurements. And it's comparing it to this pattern. Here is the pattern here replicated, and then here is what we're actually measuring in the red. And we can see that this correlates to the volume match, how much paint was applied, the shape match, the width and height, and then the angle, whether or not this is tipped one way or the other. And I think that probably what I need to do, I can find my mouse. I should be sharing my screen so that you can see this. Because what's important is that we've set limits for what our maximum deviation is. We can see here 15%. I can literally go back. I can look at this. I can hit the project manager and it will pop up, and I can set the deviation for all of these different variables, and I can set the tolerance for each of these. Now, we've looked at it and said, I'm okay with 15% variation on these, and by finish will still be acceptable. But this could be at all different amounts. I could have 7% here. I could have 12% here. I could have, here I see 50% in my SB50 variable. So there's all kinds of things that I can set up in there for my specific paint projects. Here I can see that I'm out on my volume and my shape, and it's because my width is off. So now I can go back, I can make some changes. Maybe my air cap is dirty. Maybe my shaping air. And you can have one shaping air, two shaping airs, whatever. Maybe those are not quite at the right level. Maybe my flow isn't right. I can make those adjustments. And once I've made those adjustments, I can shoot another sample. I can then come back. I can run it. I can see if I've done any better. And here I can see that my pattern matches my gold standard. Now, when I reproduce that robot program, I am going to get the same results that I originally set up for. And I have wasted how many parts? 0. I've spent how much time curing them? 0. So far, I've now confirmed my process and I haven't painted a part. Now, I can do this at the beginning of each shift. I can do it at the beginning of shift and at lunchtime. I can do it as often as I want because it doesn't take any appreciable amount of time to do. And so that's really important. It lends itself to other things. Let's say that I rebuild my guns every week because I want to make sure that they're in peak condition all of the time, because I can't afford rejects if I'm going to make my shipments to my customer. Makes sense. But if I'm doing this, say, at the beginning of every shift and at every lunch period, so I'm getting 2 points per shift, I can store these in the database. I can create folders for that specific atomizer, even for that specific paint, but more for that specific atomizer. And I can look at the drift over time. Maybe I learned that I don't have to rebuild every week. 2 weeks is satisfactory. Now I fine-tuned my PM program so that I'm minimizing the amount of time that I spend maintaining the system while still ensuring optimal quality. It's a really important feature. Now, this comparison feature actually works for a lot of different things. And now I'm going to talk a little bit about this CFAN project. And this was kind of important. CFAN has SCS temperature control equipment. We've been working with them for about 2 years now. And they are renovating their robotic paint process because of the importance. In fact, you may have heard in the news lately, there's been some problems with fan blades actually fracturing. And that's kind of a big problem. Engine failure on an airplane is a big deal. I don't think I have to explain that. They are looking to make their blades, in fact, the paint specs on their blades, even though they're inside of a jet engine, the paint specs are actually more demanding than the typical Class A finish specs in automotive. And you can see why. So they're looking at how can we improve our process. And so we went in and we did a series of tests where we used the same robot, the same paint, and we were able to run the same trials, the same paths over a range of temperatures from 70 degrees to 120 degrees in 5-degree Fahrenheit increments. And we were able to look at the impact that temperature-based viscosity variations have on the spray process. And we used the SprayVision tool as the means to evaluate that. And this comparison feature came in extremely handy. There's my mouse. You can see it's going to transfer to the CFAN directory. We want to go to the static and dynamic patterns, where we can see what's going on. And let's just pick a few of these patterns. I'll just take the 10s for convenience. And I'll just grab 4 of them here. And then I'm going to pull those into the system. The same as I can compare between my gold standard and my production pattern, I can also compare any patterns in my database. This is how I go in and look at it and say, what kind of degradation over time? And I can also see, is my first shift doing a better job of maintaining the guns than second shift? So on and so forth. Where do I need to have more training? Not intended as an operator gotcha or anything like that. Maybe they need more training. Maybe there's nobody there helping them to make them understand the importance of getting the horns clean and that kind of thing. Here's 110 and 120. I'm going to take this real quick, and I'm just going to shift this because I want them in reverse order. I can move them that easily. Notice that the patterns have shifted here. I can see the patterns out here. I can compare these two, and I can see that at 120 and at 110, I get very different spray patterns. And I actually can see the statistics here. I'm going to pay closest attention to the volume because that's my paint laydown. how much volume did I actually put on this pattern over a given area. And here I've got 724 cubic millimeters at 120 and 687 at 110. So my volume has gone down as my viscosity has increased. Well, that kind of makes sense when you think about it. My viscosity is going up. I can't get as much through the nozzle. This tends to start to make sense. And my pattern is also slightly different. I can see that my overspray area is getting a little more extreme. Let's just bounce and take a look at this compared to 90 degrees. And now we can see how dramatic the change is. All other patterns and parameters are the same path, the same speed, the same distance and angle to the surface, the same pressures, the same flow rates, the same shaping air, the same atomization air. So this is where our transfer efficiency comes from, a key word that your customers are going to be listening for, and we're going to look at that in just a second. And here we can see that between 120 and 90, I have a very different pattern. I would have a very different laydown if I sprayed with this pattern and I was expecting this pattern. And we can see it here. It drops from 724 to 578, 80%. So that's a 20% reduction in paint application. And that's important because if I'm depending on a specific film build and a specific laydown, if I lay down 20% less film, I'm probably going to have a color match problem because the film isn't going to be there like it's supposed to be. So these are the things that you learn. Now, another quick thing that I want to take a look at are what's called the deep analysis tools. And these are really, really cool. I mentioned these guys are really smart. And they came up with things that I wouldn't have thought of. We talked about transfer efficiency. We're going to start there. And we're just going to grab a pattern. Any pattern will do. Let's just grab, there's 110, that'll do fine. This depends on knowing your process a little bit because there are some variables that you have to supply, but it allows you to approximate your transfer efficiency. For instance, if I know that my fluid flow here is, say, 200 cc's per minute, and my velocity is 300 cc's per minute, and my volume solids, just for shits and giggles, is 50%. And let's say that I'm using conventional HVLP. That's what we used in the CFAN experiment, so we'll look at that. There it is. I can calculate what my transfer efficiency is based on the measurements in this foil. And I can see that it falls at 49%, well within the range of the standard conventional HVLP gun that generally falls in the 30 to 60% transfer efficiency range. Again, no electrostatics. That's important for CFAN. They don't have the electrostatic option because the fan blades are actually made of composite, so it's non-conductive. But this gives you a way of looking at it and understanding what your transfer efficiency is going to be in your process. There's a couple of other things here that are important. Droplet analysis. The resolution of the scanner is so fine that we can actually look at a specific area and zoom in right on different areas. For instance, this is out on the edge of a static pattern. And we can take a look at what happens here. Now we have to scan specifically for a droplet analysis. Well, there we go. Here we can see the pattern, and some of these dots don't look all that good, but we can see what's happening here. This would be right out on the edge of this static pattern. And that is the 120. That is this pattern, by the way. And there are some issues if you look at it. When you zoom in on them, you can see it here. And what you get are the droplet areas, the maximum, average, and the sum of all the droplets, which is the volume. You can change the units. They can be area units in square micrometers or millimeters. They can be volume units in cubic micrometers and cubic millimeters. So now I can see the areas and the total volume of the droplets in this area. And then I can look at each individual. It divides this screen into, in this case, 9 areas where I can look at my overall particular volumes or areas here. I can see what happens as I get a little closer. I can see what happens out in this area. I can see my numbers going up, and I can see what happens in this area here. Not sure why I'm getting that. But we can see how it's picking up different parameters, and I can compare those, if I want, to the total here. So it's an interesting tool. I'm not going to spend a lot of time with it, but you can zero in and you can see that you can get right down and you can look at even the individual droplets that have been applied. There's one other thing that's important, that in the deep analysis area, and I'm not going to run this, it takes a little bit of time, but I can literally run a pattern. I can put it on here and I can set this up to run a series of captures, one after another, and store them, and then put them into a time-lapsed sequence so I can see what's happening as my paint flashes off. And this is where many of the defects like orange peel and gloss issues and even pinholes and craters and that kind of thing often appear during the flash off stage. So I can run this, I can watch the flash off, and I can see the capture times, the number of captures, the total time that it'll take to run them. And then I can change the speed that I'm going to work through them. And I can see what's happening during the flash off period. Yes, the air is captured in here. It's not completely representative of what's happening in your booth, but it does show you what's happening at the surface as this paint starts to flash off. So it's another exceedingly useful tool in this arsenal that your painters never had before. One other quick question that's always come up: does it work for both manual and for automated operations? And the answer to that is yes. In fact, at CFAN, they have a manual line as well as a robotic line. We took it over to the manual line and had their operators shoot a foil, and then we scanned it to see what their atomization looked like. We did their droplet analysis. We looked at their transfer efficiencies, and we looked at what their overall patterns and films looked like. And we were able to compare those very quickly because of the database features to what happened in the robotic application. So it's a useful tool. There's a whole bunch more things that we could talk about on this, but I think probably right now, because we're right at the end of our time, and I'd just like to open the floor to questions and see if there's anything that, any questions that this has brought up, things that you guys want to know about. And I'm just going to run down through and make sure that everybody is available. Yeah, it looks like
Thanks for doing that, Mike. I know there's a lot to cover, and I know we probably didn't get through it all, but for a brief initial introduction, yeah, this is, like you said, new technology. If you got some initial questions we can answer now, or if you think you need more information, we'd be happy to go through that.
Sure. Well, thank you guys. Appreciate it. Some of us are going to have to hop off here pretty quick. We've got another 10 o'clock. But the big concern is going to be cloud security. I know this all runs through the cloud, and we've had some other technologies that we've tried to get into some of the larger companies, you know, automotive being specific, where it's been an absolute no-go. So that being some of our largest volume, how do you plan on getting around that?
So right now we've got customers in aerospace and automotive that have evaluated this through their IT departments, and it's being used in Europe all over and with the same result. It is offered in a to be hosted on corporate servers. They do make that version available. In all of the time that this has been done, and there's about 40 of these across Europe and the US right now in operation, no one has elected that option. They've all found that the security that's been put in place by the SprayVision team is adequate or even better than what they would expect to have on their own corporate servers.
Okay.
I've got a quick question.
That's a great question, and I forgot to cover it when I talked about it, so I'm really glad you brought that up.
I've got a question on clear coat. How does this work on clear?
Clear coat was originally not an option. And just over the last month, they've introduced the clear coat option. It changes the light system in the lid, and the new light system adds a UV component that they use to actually read the clear coat. And so it's a slightly different capture unit. Existing capture units can be retrofit. This can be removed and they can be retrofit to the new light source. It adds about $10,000 to the price of either unit. So it is a pricey option. It's a third of a price of a conventional spray capture unit for opaque coatings, but clear coat's important. And so I think what we're going to find is that most people are going to opt for that. Again, I said it's a third of it, and I'm sure you're wondering, you know, what is the price of this unit? The sale price of these is depending on which one you get, the A2 or the A3, and what peripherals you get with it. It runs in the 28 to 38,000 range, 38 to 48 with the UV option for clear coats.
Have you approached any of the actual equipment manufacturers about this?
Had one of them sitting at our table just last week on Monday, I think it was. So yeah, we're working with the robot suppliers. We're talking to paint suppliers, and there's a lot of stuff going on, both in the US here with us and in Europe with SprayVision.
I was just thinking of using it as a quality control tool in the factory where there's so many variables.
Yep.
They changed the design of a bell cup, for example, introduced new bell cup technologies, machining operations. There's a lot of variables inside a manufacturing plant.
True. Hadn't thought of it from that perspective, from actually making the bells and the cups and the nozzles and horns and all of that. But yeah, it could be used at that level. Hadn't thought about it from there. That's actually a super good point.
Yeah, we worked with DuPont back in the mid to late 80s with a anemometer, a hot wire anemometer, and we would develop a brass cap, which was the standard. And then we would sample air caps and against the standard and see, you know, as the manufacturing starting to drift, is the material as we machine it moving, how is it affecting the spray pattern? But we were only looking at the distribution of air. This is way more sophisticated.
But all of that is important and reflects on this. And in fact, SprayVision has assembled a lot of the issues that you see. For instance, if your pattern, like the one pattern we saw, was shifted towards one side, that's probably a shaping air issue.
Correct.
Could be a nozzle issue, but it's probably shaping air. Could be angle to the surface. But if you go and look and you confirm that the angle to the surface is perpendicular and that's okay, you can rule that out. Now you want to go look at the air caps and that kind of thing. But they've created a database of all these different things that can result in what you're seeing. And they're actually integrating that with the software. And it's not up just yet, but will be shortly. Those will be available. You can hit the troubleshooting tool and it'll pop those right up and suggest for what you're seeing, you want to look at these things. The one other thing I should note in here, because that links over to the video manuals, in the software, in tools like that are being made available all the time, and they have just real short, quick videos on how to use the different features. For instance, I haven't done calibration in a while. I kind of forgot how I'm supposed to do that. How do I do that? Here's a 9.5-minute tutorial that walks you through that entire process. And when you're done with that, and I know because I used it when we did this, you're an expert on calibration again. So they're including tools like this built right into the software. Another good reason for having it in the cloud. As they add them, they become immediately available to you on your next login.
I was wondering if you had any data from, you know, it doesn't have to be automotive, just general data that's been taken from the bigger scanner. I'd like to see what those patterns look like.
Oh, well, just a minute and I'll show you. There is a way that I can do that if I can get...
I would
Is that
assume
something you want to follow up with, Bruce? I know you said you had to leave at 10, but
yeah, these guys got to go, and I'd like them to see it too. So I'd like to maybe, yeah, we can get into a little more detail.
okay. Yeah, we can certainly set that up. You know, we can put something together, I think, Mike, and then, you know, schedule another, you know, meeting. I can get with Stu.
And here, just very quickly, here's an example.
Okay, it's kind of what I expected.
You can see this is the A2 foil with a bell pattern right there. Here's the scan that was taken. Just as an example, just a real quick example. There is a lot of data available at SprayVision, and we can get more information. If there's something in particular you're looking for, hey, let Mark know. We'll get that information from him.
Yeah, it's a good point, Mike. Good questions too, Bruce. Anything else, guys, before you head out?
No, I'm good. That's a lot of good information.
And if you guys got questions after the fact, don't hesitate to either give us a call or send an email. We'll get those handled for you, and then, you know, Stu and I can, you know, schedule some kind of follow up with some more data, more specific data.
Okay.
All right, guys.
All right,
Thanks, everybody.
Thank you.
Thank you. Have a good week. Thanks, Mike.